Hi, everybody. Good afternoon. We're getting started a little early just to make sure we have enough time to cover through our presentations today. Very glad to have you all here. We have here today with us Tim Holman from Toyota Motors North America. Dr. Michael Nolting from Volkswagen. And Dr. Mohammed Al-Rafai from Volkswagen as well. So we're going to be talking about autonomous driving here today. We have wonderful presentations from both these companies. Before we begin, I'll get started with just a few slides about what AWS is doing in the ADAS and autonomous driving space, and hand it over then to these gentlemen. Thank you very much.
Okay.
So before we get started here on the autonomous driving part and AWS's involvement, I just want to have touch briefly upon what AWS for Automotive is and how we're thinking about the automotive space and the automotive ecosystem as a whole. So we have an automotive business unit within AWS that's focused on working with our major OEMs, tier ones, and other retailers and other customers in the automotive space. And what we've done is come up with what we call strategic workloads. We have 8 of these strategic workloads here that you're seeing represented. And fundamentally, we're connecting all of these 8 strategic workloads through a centralized data lake of sorts. If you look at it, the way we've classified this is we have digital customer engagement. This is how you do your configurators, your vehicle purchase, your sales, marketing, and all of that. We have product engineering, which is the core vehicle development aspects, the physical aspects of it, the driving dynamics, the noise and vibration, the crash performance, the durability, so on. And then we have manufacturing, which is about the capability to be able to scale up, produce a certain number of vehicles, minimize waste, being able to use that data to improve manufacturing processes and manufacturing efficiencies. And then supply chain and logistics, as we've seen through this whole pandemic situation, how much supply chain disruptions have an effect on production of vehicles. So we're very involved in that area and trying to help build supply chain transparency, being able to build logistics capabilities from our experience in the logistics world and share that with the automotive industry. And then the domains that we see are up and coming or more modern and added value to a lot of the car companies and to the customers are in the areas of software-defined vehicle, where we're looking at how we can enable, as more and more software gets into the car, how can we enable the complexity of that software to be built, developed, deployed in a more seamless manner. Connected mobility services with the advent of 5G and CV2X. What are the advantages, what are the types of services that can come into the market as an application of the connected mobility capabilities. Autonomous vehicle development, I'll talk about that in a little bit more detail in the next couple of slides. And then sustainability, which is key and is on everybody's minds today. And we also have demos around how sustainability is critical to a lot of our customers in terms of the vehicles, not only the vehicles they produce, but in terms of how their operations themselves have to be sustainable for them to meet some of the CO2 emissions targets. Moving on, what we see within, we've gone and interviewed a lot of different customers in this area, and what we see as we've evolved as AWS over time is that in the automotive space, customers would really like to see more products over self-serve building blocks. We've been very, very good over time at offering these types of self-serve building blocks that are very capable, that can scale horizontally and scale across multiple types of industries. But what we realize is the automotive industry has a certain set of unique requirements. Safety is a top priority. So what what we also notice is the automotive engineers don't want to sit there and try to build out these capabilities on their own necessarily. So they want more packaged services, and that's where we're coming in with this products over self-serve building blocks. There is also a lot of interest in having our AWS services customized for the automotive industry. A good example of how we've done that is IoT FleetWise. It's been announced here at re:Invent, and you can see the kind of capabilities it offers that's very specific to automotive, meets the requirements. And then the third thing is really enabling a lot of our partners on AWS, because what we also realize is the automotive ecosystem is extremely complex, and there is no single player that can necessarily do everything. So we need to work with various types of tool vendors, various types of system integrators to be able to deploy this in the automotive industry for our customers. And our key value proposition, if I have to summarize it in a simple way, for the autonomous driving aspect of it, is that one, there is a huge need to be able to scale up quickly and in large volumes, given the amount of data that gets collected, the amount of data that gets processed, especially if you have video streams, you have heavy sensor data, the amount of storage that you need and the amount of compute that you need. It's just the only way to do this is through a hyperscaler, through the cloud. We also see this need, the second thing is we see this need to shift left, where you want to be able to do a lot more upfront validation, upfront analysis before you start getting hardware into the loop or hardware into the mix. So the more you can do virtually, the more you can simulate, the faster your development process gets and the more efficient it can get. So that's part of the shift left. The third thing is we have a large community in the space of AV and ADAS. We ourselves have been involved with some of the robotics efforts with Scout and with some of the other programs. We've also worked very closely with a lot of different level 4 autonomous vehicle companies and have been able to use that knowledge and that learning to share that across our automotive ecosystem. Last but not the least is being able to collaborate across different platforms and being able to work with hybrid solutions where sometimes there are customers that might want to use some of the capabilities for data centers on-prem, for hardware in the loop type applications. So being able to work in these kinds of hybrid methodologies or these hybrid capabilities is also critical for our customers. With that said, one of the ways, and this is the critical part that I want to kind of talk about a little bit more in detail, and then I'll hand it over to our next speakers. The way we look at being successful in autonomous vehicle or ADAS development is to think about it from a data-driven approach. Now, this flowchart or this process that we're highlighting here is a courtesy of ASAM, which is a standardization organization based in Germany. And we've looked at how they've presented a standardized process for data-driven development, and we've adopted that process. And we think that this is one of the best ways for customers to be really efficient with how they get to their end feature or function that they need to develop for autonomous driving. So it starts with the data collection, the data ingest, potentially being able to process the data at the edge as well, if possible, and then moving the relevant data into the cloud. From there, you can go into labeling, into tagging all of that data, making sure that you have the right metadata stores, and then applying your compute for machine learning and for training the models so that they can be then deployed into the vehicle. But before you do that, you do a lot of validation and testing from a software in the loop perspective. That's what SIL stands for, and this is where simulation tools come into play, where you create virtual replicas of the 3D environment, of the sensors, of the physics of the vehicle, and so on, to be able to make sure that the features and functions you're developing can actually perform as you expect them to meet your requirements, your KPIs in that space. And then from there, you can go into what we would call soft HIL, which is HIL stands for hardware in the loop, where even before you have the actual hardware, you have virtual representations of the hardware that you can test against and validate your code against. and then you do your final validation on the hardware in the loop benches on the actual hardware itself, and then deploy it in the vehicle, test it out, and then anything that you find again from at that point in the vehicle, any challenges or any issues that you find, you feed it back into the cloud, into that data lake, so you can go through the process of validation or testing and refining that process over and over again. So to enable this, you need a data lake construct, which is what we've been focused on, and we've built out these types of data lakes for various customers. And this is key to where and how we are evolving as AWS to help our customers in this space. With that said, I think it's time for the next presenter. I just wanted to give you that overview, and now we'll hear from Dr. Michael Nalting from Volkswagen. Thank you.
So thank you very much, Karthik, for the nice introduction. And as already mentioned, I'm Michael. I belong to Volkswagen Commercial Vehicles, and I'm head of the Department of Digital Service and Data Analytics. And what you see on the next slide is our T1 van, our iconic past, right, and our future, our ID bus. And our ID bus is the answer to the customer demands of the future. So that cars are supposed to be electric, of course, connected, available via ride-hailing services, and of course, and this is what this talk is about, autonomous, right? And we really tried hard to bring such an ID bus to the United States, but finally we did not succeed. It will be released in 2 years, but I was able to smuggle one into my suitcase, and it's this little fluffy version of my ID bus, right? And you will be able to win it. So on the next slide, there will be a question, and the best answer, or the most accurate answer, we will be able to win this, and I will throw it in real time right to any direction in this room. So what you see on this slide is that there is a disruption going on in the automotive value chain. I guess we heard a lot about this. And what is so crazy about this disruption is that, of course, there are changes in terms of the customer demands, as already mentioned, but there is also an exponential rise in terms of technology. I guess yesterday there were several sessions talking about this, that there are, of course, a lot of data now available to train awesome models, like, for example, deep neural networks, where there were big improvements in recently that you can train them and they achieve high accuracies. And of course, cloud technology is very important, that you are able to spin up thousands of EC2 instances, for example, and train these models. And maybe you have looked into GPT-3. I did it some month ago, and I was really amazed about, for example, the results which they create, right? That you can use them. There's an AP3 available from OpenAI, and the results are so good that you cannot decide whether this is, for example, from a human, has been created by a human being or by a machine. And this is what it's about, passing the Turing test, right? So we are currently at a point, at a turning point, I would say, where it is really crazy what's going on currently in terms of technology. And now let's give me a concrete example of this exponential growth. Imagine that you sit in a stadium, for example, in the SoFi Stadium in Los Angeles, and you watch a game, maybe the Super Bowl, and you sit there in the highest row in the nosebleed section, and you watch the game, and let's assume that you have a magic pipette, right? So this pipette, which is able to dispense little tiny drops of water, for example. And the special thing, the magic about this pipette is that it doubles the amount of drops every second. So it starts with 1 drop, then 2 drops, after 3 seconds, 4 drops, 8 drops, 16 drops. Probably you get it, it's an exponential growth. And what do you think? And now the question, right, time for winning. This ID bath, this fluffy thing is, what do you think, how much time will it take until the entire stadium is filled up to the brim with water? Is it months, is it weeks, is it minutes, hours? Seconds. And how much seconds, what do you think?
30 seconds.
Anyone else? Sorry? 16. So it's 49 seconds. So this goes to you, right? Catch it? Very good. And the crazy thing about this is that, for example, 4 seconds before, after 45 seconds, you would sit there, watch the game, and you would feel completely safe because the water would be a little bit flooded with water, right? So the ground would be a little bit flooded with water. And you would feel completely safe, and 4 seconds after, you would be drowning in water. And this is what exponential growth is about. And now, based on the fact that, for example, the last 60 years, there was this, the Moore law was true. That means that every year the size of the chips doubled or the CPU power increased. It's a valid point to think that maybe based on this fact that the last 60 years, this was true, the next 5 to 10 years can be really game-changing in our industry. So and now the question is, how can you prepare as a big corporation? And the answer is that first you have to master the digital transformation, right? You have to design your company in terms of a maximum of flexibility and agility. That means that you're able to adapt to these changes, this exponential growth in terms of technology, changing customer demands, and of course all this crisis currently going on, inducing instability into your system. And the big players, like for example Amazon, Facebook, and so on, they are digital natives. That means they have an infrastructure which is able to adapt. They are able to release their software several times a day, right? This is what we are currently not really able to do. So as an automotive company, we are struggling really with achieving this high release rates, but we have to do it to master the digital transformation. And the next thing based on this is you have to master the data transformation. That means you have to use all the data that you have to take the risk out of decisions. And this is the reason why we started implementing such a platform to support our team developing autonomous cars, because it's a very complex journey and you have to use all the data that you can get to take the risk out of the decisions. And this is the point where I would like to introduce the best data engineering data scientist in the world, Dr. Mohammad Al-Rifai. Thank you.
Thank you very much. Very good.
So thank you very much, Michael. I'm glad to be here and to tell you a little bit of how we use data in our brand, commercial vehicles, to make our products better and make our customers satisfied. Not just for autonomous driving, but also for all other kind of vehicles that we are developing. And as you see here, there are a couple of products that we have at this brand. The last one is the ID bus that you see now is the electrical vehicle. While developing all these vehicles, we try to use the data as much as we can so that all decisions that we take are data-driven. So how we do that is that by collecting data from our test vehicles. When we develop new vehicles, new models, we do extensive testing of these vehicles on test tracks. We drive them for hundreds of thousands of kilometers, to simulate all possible usage profiles that we know from our customers to make sure that the vehicles will be always at the best. And we also collect data from some selected customers where we have agreements with them to install some data loggers in their vehicles to get better understanding of how they use the vehicles. Because remember, we're talking about commercial vehicles. They are mainly used by business, and how they use them depends always on their business. So the usage of the vehicles is completely different from customer group to another customer group. And that's why it's very important to understand how they use the vehicles in order to make them better. And this is what we do when we talk about vehicle analytics, data logging, then having some analytics solutions to analyze the data, to generate some insights, to understand the usage profiles, the driving profiles of these vehicles from different customers, to be able to design the best simulations and test procedures, and then make these products better. Now we have yet another product. We're talking about autonomous driving, the ID bus, AD, and again, we do the same. We have to collect data, we have to test it extensively, we have to understand how try to compare it with the usage profiles of the users, make sure that it will also satisfy all the requirements. But it's not just another vehicle like other vehicles. It has also its own challenges, of course. Because, first of all, well, it's autonomous. There are no drivers. We want to use them for providing mobility services in the future. So in the future, we're not talking about producing vehicles, but producing mobility solutions. We're talking about mobility as a service, transportation as a service. So you need to make sure that these vehicles will be suitable for this kind of use cases. There will be, we are in the brand responsible for autonomous driving in the group, actually. We are responsible for developing these mobility as a service, transportation as a service for the whole group. And the goal is that we, with our ride-hailing service, MOIA, which is already operating in Hanover and in Hamburg in Germany, to make this fleet autonomous by 2025. This is, of course, not an easy task. This is a very challenging task. But in order to get there, you need, of course, to use all the data that you have. We have already data today from all customers that are using the vehicles for transportation, for moving people from A to B. We have data from MOIA as well. And we're trying to use this data to make those autonomous vehicles in the future the best as much as we can. In addition to making sure that these vehicles will be the best case and the best quality, we have also to make sure that safety is also assured. This is very crucial, again, because, as I said, it's autonomous driving. And I'm not talking here about the development of self-driving systems. So when you hear about autonomous driving, most of the time you think about using data to train some machine learning models to make these vehicles able to drive autonomously. I'm not talking about this. I'm talking about making sure that the vehicle which will run this software is ready. Before we operate those, before we bring those cars to the road, we have to make sure that they are ready. And that's what I'm talking about here. So trying to analyze the data about the usage of the vehicles and making use of all the sensors that we have, and then take the right decisions based on the data. And it's also important, crucial here, that we have all the data provided for everyone who needs it at all decision levels. So I'm not talking just about data scientists, people who work machine learning engineers. I'm talking about the vehicle engineers. I'm talking about management. Everyone wants to understand how the development is going. Are we on track? What do we need to do to make it faster, to make it better? And that's why you need to make sure that all the data that you have collected are accessible to everyone in every group. And that's not an easy task. And for that, you need to have a very good and very scalable solution. It starts by thinking about how do we get the data from those vehicles to the cloud. Then how do we ensure that we have scalable systems that can deal with these huge amounts of data that we are getting. You try to automate the data processing, the data preparation, the extraction of features and KPIs as much as possible so that you get access to this insight as quick as possible. And also you need to provide some analytics and visualization tools to the different target groups. And we're talking about very diverse groups of users of the data. As I mentioned, vehicle engineers, data scientists, business analysts, and also management. And this is what I'm trying to show you in the next few slides, how we do that, how we tackle this challenge. We did this within the project in our brand, which we call SNOWPARK. So the solution we developed on AWS cloud, we call it SNOWPARK. And here is very high-level architecture of this solution. I'm going to explain the different parts, the important parts in the next few slides. So we start with data upload. We have here to think about how we get the data. So we have vehicles in the field. We have vehicles at the customer side. We have vehicles that are driving in our own test tracks. So different locations. Some are in Germany. Some will be also in the future also outside Germany. You want to make sure that you always get the data as fast as possible and upload it as soon as possible. And for that, we have developed specific solutions that we have on-site where the data loggers that are used collect the data, and then you need just to copy the data to this solution, which is on-site, and it will automatically start uploading the data. For making sure that the data is synchronized, we use services from AWS like Data Sync, which will make sure that as soon as new data arrives, and new data is collected, it will be uploaded to the cloud, to the S3 storage. Now what we are looking at is to use to replace our own specific solution for uploading the data with the snow cones. The nice thing with snow cones is that then you don't need to do a lot of software, own software development. It can be configured to be usable with data sync, and it's also portable. And in the future, we'll have more and more sites, as I said, worldwide, where we have those test vehicles driving, and we want to get the data as soon as possible. So that's why we're looking into the use of snow cones. When talking about S3 buckets, I mean, I think everyone using AWS uses also S3 buckets for storage. But the nice thing that we found here is that it's not just cost saving, but it's also possible by using intelligent tiering to reduce the cost very significantly. I mean, we have data which is growing. The data is growing very fast. And by using intelligent tiering, we're making sure that the cost will not increase as fast as the volume of the data is increasing, which is a very nice thing and very important aspect. Now, you have uploaded the data. You have found solutions to how to get the data to the cloud. The next step is how do we process the data, these huge amounts of data. And the best would be, of course, if you do this automatically. And for that, we have developed pipelines for processing the data. We're using services like Lambda functions. We use also SQS. And by building pipeline of a series of Lambda functions and SQS, we're making sure that the data is processed as soon as it's uploaded and is prepared for usage by the different user groups. We do transformation, conversion of the data. We move from what we call bronze data to the silver data, where you have it in standard formats like Parquet or JSON, and then start extracting some features from the data which can be used by the different groups and move it into what we call gold data. It's very structured, very well prepared. You can just directly plug in any analytics tool, any visualization tool, and start doing your own analysis. And this is, of course, makes it very handy for different users, because if you see the raw data, how it comes from the vehicles, it's huge, a lot of signals, a lot of time series, so complicated. Not everyone can understand this data. That's why you need to prepare it to make it easy and accessible to everyone. And for that, you need, of course, this kind of automatic data pipelines. Now, we have still some advanced users, I would say, who want to do some more analytics, more advanced analytics with the data, not just using the results of our pre-processing, but do their own analysis, their own processing. Let's say they have encountered some challenges, some problems in field, and they want to take a closer look into the raw data and do some advanced analytics to understand what was the problem and how we can tackle that problem. They want to have access to the raw data in the cloud. And for these kind of users, we also build what we call the analytics workbench. So every data scientist has his own workbench instance where he has all the tools that he needs for his analysis. He gets, for example, an Amazon AMR cluster to do Spark analysis. He can use SageMaker to do machine learning. We use also elastic file systems for sharing data between different data scientists. We use, everyone has his own instance of a MySQL database where he can store the results, but also can share this database with other data scientists to work together on a specific problem. And this is something that we provide them seamlessly, so they just need to have an account on SNOWPARK and just start using it. They don't have to care about how this is provisioned. And once they have the results that they want to share, they could put it in a central database. And as soon as they have some routines that they use very frequently, we could then take them and integrate them in the automatic pipeline processing so that everyone gets the data automatically. So here are just a few examples of what we do with the data, just to be a bit more concrete. When we're talking about self-driving system monitoring and validation, one of the things that our users are doing is like what you see here to the left side of this slide. For example, trying to reconstruct some situations, some driving situations, not using the more advanced sensors like LiDAR, radar, and so on of the autonomous vehicles, but using the basic sensors that you have in every vehicle, in the ID bus vehicle, the base vehicle for this autonomous project. and trying to reconstruct this, do map matching, and see where they were driving, how was the driving situation, and if there were some errors or some problems there, and understand the reason behind it. And this is something you can do now using our analytics workbench on SNOWPARK. By doing so, they can have a better understanding of how well these systems are working. And this kind of a black box testing of this SDS solution. Another use case is monitoring of the ODD coverage. By also using this data that we have collected with the data loggers, they can see how well are we covering this ODD, and where do we need to do more testing in the field or on the street. So this is just a very basic examples of what they could do with this solution and how they do the validation and the monitoring every day. But that's not everything, but we're not just doing this black box testing of SDS, while this is actually the main use case of the use of our solution of SNOWPARK, still we have possibility to use this power of the cloud, like SageMaker, Amazon AMR clusters, to do a bit more analysis. And one of the things that we do is, from an algorithmic perspective, is to also do some solutions, or to try to develop some new models for autonomous driving, like motion prediction. And here's just an example of a research work a PhD student have done on our system, and it's published at the conference for intelligent transportation systems this year, where he is trying to analyze the situation in a given scene by giving the data about their own vehicle, but all the participants in the scene, and by analyzing the last few seconds, trying to do a prediction of the motion of every participant in the scene for the next 3 seconds. And this is something that you can do, of course, with this SNOWPARK, because you have SageMaker as an example, where you can analyze a lot of data in a very short time. So at the end, what we have achieved with this solution is that we are kind of democratizing the data. We're getting now to the land of data, which Michael mentioned before, by making the data accessible to everyone in our brand, all different groups on all different levels. You have, on one hand, the business analysts who just wants to have insights, to build their own dashboards, to have kind of KPIs and monitoring the progress of this development of the autonomous driving. You have, on the other hand, some technical features, some vehicle engineers who wants to take a closer look into some specific driving situations and the performance of the SDS in that situations. But you also have data scientists who can do their research and take a look into the data from algorithmic perspective, or maybe develop new models for the future autonomous driving. And this is exactly what we mean when we're talking about getting to the land of data, and we're very glad that we are there. And that's it from my side. Thank you very much. And giving back to Karthik. Yeah.
Thank you, Dr. Nolting and Dr. Al-Rifai. That was a fantastic presentation. I just wanted to introduce Tim Holman from Toyota Motors North America, and we'll see how they collect data and do a lot of edge-to-cloud processing for ADAS development at Toyota. Thank you.
So good afternoon, everyone. Again, my name is Tim Holman. I'm a senior engineering manager at Toyota Research and Development in Ann Arbor, Michigan. So a little bit about us and who we are. TMNA is Toyota Motor North America, and we are in several pillars, and I currently work in the R&D pillar in the Integrated Vehicle Systems Division. We commonly call Integrated Vehicle Systems IVS. So if I use those two interchangeably today, I apologize, but that's the acronym that we use in Toyota, because we speak in acronyms at Toyota. We are very much a multidisciplinary team. We have folks who are the folks developing the code that goes in the vehicles, all the way to the technicians who are driving the vehicles for evaluations, and everything in between. So ultimately, our team is responsible from cradle to grave, if you will, for many designs, including all the evaluations and the deployment in our facilities here in North America. Overall, Toyota's mission is very simple. It's mobility for all. And Mr. Toyota established that vision for us a couple of years ago. In our case in IVS, our goal is to make our vehicles safer, more productive, and give features to the members and the customers who use those vehicles to make our vehicles better for their daily use and make their mobility better. Ultimately, again, as I said a few moments ago, we're responsible from beginning to end of the development process cycle. And in our division, we're actually beginning to take lead globally for many of these activities. One of the key activities that we did recently is we were the lead for the 20 TMNA product, which is Toyota's first foray into an automated driverless vehicle. So jumping into really what we do, and we're talking about today, is really talking about scaling out edge to cloud. You know, we all talk about how much data that we generate, and the answer is it's massive. So how are we going to move it from the edge, from the vehicles, into the cloud, and then make our vehicles better, you know, as we go forward? So ultimately, a lot of the designs start in Japan, okay, and then they bring them into the various regions, in our case into North America. So you can see some of the complexity that's there and some of the problems that we face in our day-to-day activities. You know, those challenges really talk about the growth and the scale of what ADAS has done. Several years ago, we had a couple of cars we were testing. Today, we have hundreds of cars that we're testing. So that also leads into the second item, which is obviously with more cars, there's a lot more data. And not just more data because of the number of cars, but because of the number of sensors and the complexity of those sensors, and lest we forget video, right? So that ability to scale the data and the ability to collect that data and analyze that data is key, which is really that third point is our time to answer, right? When we have an issue in development to verify if we're doing the right things, we need to be able to shrink that time to get the developers that response very quickly from when the vehicle is driven to when they see the actual results so that they know that they're doing the right things going forward. And then finally, Yoko-tenning that across the globe, right? You know, everybody says it's one Toyota, and that's true, but there are many entities and divisions and pillars in Toyota, and our ability to be able to Yoko-ten and move that across the regions is really a big challenge for us and with the inertia inside of a large company. So we talk about some of the things that we do, and from a developmental process, one of the things we talk about in our process is identifying the ideal condition, identifying the current condition and the gap between those two, and then ultimately countermeasuring those activities through Kaizen activities and continuous improvement. We do that in our development process through Scrum or Agile in our processes, developing incremental improvements while meeting the development lifecycle timing. So how do we do that? How do we do this edge to cloud journey over the last several years? Well, a gentleman in the stands here today, William Finale, did an A3, which was a problem-solving activity to say, what do we need to do to get better to be able to get this data that we need? And it started with something very, very simple, right, and having everything manual. You know, good old-fashioned attach the disk from the vehicle to a laptop, upload the data, and do everything literally by hitting the buttons every time. Very, very painful, very, very rudimentary. Then we moved into a second activity where obviously as engineers we want to make things bigger, badder, faster. So underneath Billy's desk is a stack of workstations to do it bigger, badder, faster. So yes, it was an incremental improvement, but it wasn't where we wanted to go ultimately to get to our goal where we are today. Billy then convinced our leadership to be able to develop what we call an MVP, a minimum viable product. So we productionalized what Billy's idea was and were able to take that idea and do the right things from a technology standpoint, do the right things from a cyber standpoint, and allow us to do that stuff at a very higher scale, yet getting better and more sophisticated in the way that we do it. And finally, we introduced what we call a smart row using the Acro data system. Basically, what that allows us to do is to take that scale up even faster, to do all the data cataloging and do a lot of script activity against that data to create usable data for our teammates, ultimately shrinking our time to answer from months to days. But ultimately, that goodness chart that you see here is basically getting bigger and badder, but keeping it simple and taking some of that pressure off of Billy so he doesn't have to do all that activity every day, right? I think the phrase I'll use a lot today is easy button, right? In a perfect world, I want to load the disk, hit the easy buttons, and walk away, and within minutes get the answers to where we stand, okay? Ultimately, that's where we're driving for so that we can Yoko-ten those products, not just from North America, but to Europe and back to Japan, and share them globally, share them across functions, and share them across processes. Just because we do this in R&D, that's no different than an edge activity that we'd have in a manufacturing plant. How do we take those same skills and those same processes and Yoko-ten them across Toyota to make Toyota better as a company by the effort that R&D has placed forward. So what was the ultimate solution that we looked at? Ultimately, it was an edge-to-cloud data ops solution. I'll talk about data ops a lot today because a lot of times we as IT people forget what ops is about when it comes to how a business is going to run the actual process, right? And how we can make it more efficient for them and collaborate not just with IT but with the business to come up with a business solution. So often it's so easy to forget technology is not the answer. It's the business value that we generate is the answer, and how do we do that? Secondly is how do we create a next generation architecture that will allow us to scale, that will allow us to take this to multiple regions and ultimately accelerate our process so that we can do things and deliver things to our customers more quickly and add more value to the process. Okay. So from a future standpoint, and we're kind of in the future where we are today. We literally just moved the Smart Road 2 weekends ago into our new facility. And ultimately, we are back to being able to produce at the levels that we'll talk about here in a couple minutes from a scale standpoint. But our goal was pretty simple. We wanted to take all the workflows and on all of the KPIs that we use to measure our products and all the ability to visualize those KPIs and search that data to allow us to get there more quickly so that any member of our team can get there. It doesn't take some data engineers to do it. Any member of our development team can do that activity, yet while integrating the services that we need for authentication and authorization and single sign-on and all those bad things that people don't like to do, but we need to do from a necessary evil standpoint to make sure that our data is safe. You know, some of the things that we talked about a couple of weeks ago inside of Toyota was how do we deal with that encryption and that ultimately that anonymization or obfuscation of data. Today we know that the privacy laws are changing. We have GDPR in Europe, we have CCPA in California, and we have 9 other states that are adopting some variants of that. How are we going to deal with that and ultimately be successful, right, to maintain people's privacy and what Toyota would call respect for people? Ultimately, Accurate Data is kind of our connectivity tissue to do that. It allows us basically to use all the goodness of the AWS resources, traditional compute and S3 buckets and all those great things, right? But integrate that into one platform across all of that to make it look like one seamless integration so that literally when we receive those disks back in from the vehicles, we can place them in the device and hit the proverbial easy button and make that stuff all happen at scale, okay? So ultimately, as we go through some of the activities and some of the benefits that we've seen, let me digress here a second and talk about internal and external. You know, I talked about many times in Toyota, we are siloed in our pillars. In our case, I'm in R&D, so I focus on R&D's activity, and I don't think about the other pillars that are there, like manufacturing or distribution or whatnot. How can we use that to go forward and educate people? So literally at this AWS event, I've met with more ITX people to talk about how we do that, right? How do we make this solution better and more accessible to everybody, both internally and externally, because we have external folks too that help us develop our products. How do we share the data, the right access, to make sure that we are providing our internal resources and our external resources what they need to do this job quickly and effectively while producing a better product faster. So some of the benefits that we've seen, we've really deployed a pool-type system from the edge. Literally, that begins the entire process, and the entire process from the moment that the disk is entered into the system to when we hit that proverbial easy button is pushed through the system and pulled ultimately to the end to the KPIs that the developers use to determine how good or how bad a process is working. Secondly, we've shortened the time from our ingestion process significantly, okay? The unit of measure I'd used before would be months. The unit of measure today is days, and I will tell you we have plans to make those hours or minutes so that in a perfect world or an ideal condition, our engineers can see the performance of these vehicles as we're driving them to see things over time and make adjustments appropriately. Thirdly, is we've taken the time to create what we call standard work or templates, okay, so that we can have a standard work created for project A, and we can Yoko-ten it or copy it to project B and make it go forward more quickly. Certainly, we would Kaizen things and make things better from version 1 to version 2, but ultimately, we're not starting from ground zero. We're able to take these templates and move them not just inside of North America, but inside of Toyota globally to make that whole process go more quickly and more effectively for everybody. Probably one of the biggest side effects about this is, I'm not sure about everybody else's organization, but ultimately, in Toyota, many times we argue about whose data is right? And we try to say who calculated this or calculated that, and how does it come out? By having these standard templates, we all have the process, okay, to say, here's the number, we all agree to the number. So in fact, recently, IVS has been asked by our global company at TMC to take the lead on these pipelines. So we all have that one standard answer because of the processes that we have in place that we're showing you today. Ultimately, the fourth one's probably the most one important to me. It's eliminating that resource muda. We were pushing Billy and his other teammates, Noah Einstein and Colin Dass, very hard to get these things done. And they were working really diligently to do so and working really, really hard. So this process has allowed us to work a little bit smarter and to take some of that muda or that waste out to help take some of that pressure off of them and help to ultimately try to improve employee morale. We all know that it's very tough in this market today to find highly skilled men and women for these positions. So anything that we can do to simplify or standardize or automate a process, we want to be able to do to take that burden off of those team members and let them do the value-added work of the analysis and the development to deliver that value to our product and to our customers at the end of the day. So ultimately, again, scale, biggest issue. Time, reducing our times from months to days. Talking about sharing that data and yokotating it across not only North America, but globally. And finally, continuing that process to eliminate muda and make things go a little more quickly in a flywheel-type mentality. All right. So what are some of the physical benefits that we've seen? Okay, as I talked about a minute ago, that time delivery months down to days. So roughly 5 times faster. We're literally being able to get these things into the plants, okay, without shipping disks. We used to literally mail disks from the US to Japan. Okay, literally. So think about the number of stamps we had to put on those suckers to do that. And of course, all the extra disks to deal with all that extra transit time, right? Secondly, our capacity piece. Back in the early process here, we were talking, gigabytes was kind of the capacity. We can now do petabytes. We all joke about, how much scale is scale, but we can literally today do petabytes a week to upload this data to do our vehicle evaluations. And with a lot of great engineering work from our IT folks and from Billy and the team, we know what the bottlenecks are, and we can make that number even bigger and scale even further with the hardware that we have today. Ultimately, that scale piece is huge for us. As we are taking more lead across North America and more lead across the globe, that scale is going to ever increase. I talked about the number of vehicles that we have in place. That number of vehicles is always growing. The number of projects are growing. Adding in other products for trailers and for other lane keep assist, and all those things are growing from a product standpoint because the ADS business segment is growing for all of us from the automotive industry standpoint. These last 2 points are the points that I really get the most excited about, and it's really taking things and simplifying the operation. I can remember some of the things that when I first came into the IVS organization that we talked about how hard it was to do some of these things because everything was kind of brute forced or manual. Little things like developing a web app that allowed our team members to be able to go through this entire process and ensure that we had poka-yokes in place to make sure that the right disks were uploaded to the right bucket, to the right process, right? Something that Accredata stepped to the plate and did that very quickly for us so that we were able to make it simpler for our team members, but yet ensure the quality of our processes to make sure that we were able to analyze the information more quickly and continually evolve our processes as we go forward. So kind of that blurring of IT and OT from a technology perspective. The next piece is the resiliency. Every time you try to load a disk, what happens? You have some kind of a disk error, something dumb happens, right? The ability to be able to go in and in the middle of a process, have something fail, but restart it from there, not have to start from zero, right? So we're talking multiple disks a day per multiple vehicles. If I have to start from zero, it's going to kind of crush us, right? So ultimately, our ability to be able to manage that is very, very important. So ultimately, the lessons that we learned is we really employed the Toyota production system into our development process. Our key activity is customer first. Always think with a customer mindset and what will help our customer and benefit our customer. Using what we call the thinking way, using tools like Kanban and Kaizen and Yokoten and elimination of waste or muda. Those are the thinking way challenges that we challenge ourselves with every day to try to drive the development process. Secondly is an end-to-end view of everything. So instead of trying to maximize each individual piece, we looked at the whole business process from the vehicle all the way back to the data analysis. What can we do to make that whole process more effective and happen more quickly to get the value to our internal customers as well as to our external customers? And this third one's kind of really appropriate here at reInvent is the one thing I know that everything is going to change in technology, right? We've heard how many announcements yesterday and today about new technologies and new techniques that we have to understand and evolve, right? It's not just the platforms, for example, that AWS provides, but think about the sensors and the ability for cameras and lenses and all those things that change. We have to be able to understand that, absorb it, and have a process to be able to manage that. And ultimately, design for fundamental infrastructure needs to be able to collaborate. Who has access to the data? How are we going to set up the S3 bucket so we can do that globally? How can we make sure that we have a CI/CD pipeline to make sure as we're Kaizening this activity that we're in control of that process? And these last two, the DevSecOps and the data privacy, those are massive. You know, back when I started using a computer with a TI-99/4A, I didn't have to worry about data security, right? It was just something you didn't think about. Today, we have to worry about all that activity, and with all the rules and laws changing around privacy, to be respectful to people, we have to consider how we're going to do that, yet make sure that we have the ability and the data to develop our products appropriately through our business processes. So I want to give a big round of thanks to several folks here. First of all, some folks from the Acro Data teams are here. Kunal was extremely implemental in us being able to do this, helping us to learn what we can do, kind of the art of the possible. So thank you to Kunal for all that activity. I also want to mention Billy's name again. Billy, Colin, and Noah were phenomenal in going through this activity, constantly going through that Kaizen and PDCA process to drive through and deliver that value to ultimately to our customers. And ultimately to AWS for being there for all those simple things to get us through the process. It seems sometimes a little bit simple that we just kind of assume it all works, and it does, but we have to understand that the pieces and learn through that activity. So my challenge to everybody with that is take what you've learned today and listen and see what's the good and the bad. Just because we did it this way doesn't make it necessarily right for your organizations, but understand how that fits with your business value and how we drive that business value, but never forget that people drive that value, and whatever you can do to support your people, that's ultimately the best thing that we can do for each other, all right? So with that, thank you very much for your time today. I appreciate everything, and thank you.